Undoubtedly, generative artificial intelligence is restructuring society and changing the landscape of every industry, whether it be in banking and finance, scientific development, media, and much more. According to McKinsey, Gen AI has the potential to add $2.4 to $4.4 trillion of value to global economies, with projected scenarios involving 50% of today's work activities being automated by between 2030 and 2060. This has been complemented by the unprecedented uptake rate and flurry of Gen AI tool releases like ChatGPT. But what actually is Gen AI? How can we enhance our understanding to allow us to exploit its benefits further? Going beyond simply structuring information, generative AI is a subset of deep learning that focuses on the creation of entirely new, unique, and innovative data and content without the need for predefined labeled datasets. The underlying technology relies on nothing more than neural networks. As covered in another one of my videos, a neuron is the simplest building block of a neural network, housing its own unique set of numbered weights and biases. A number of inputs are taken in, summed together in a weighted fashion, passed through an activation function, and an output exits the node. Nodes can be stacked together in layers, and layers can be arranged sequentially to form a neural network. The network weights and biases can then be tuned with a dataset where both the input, the question, and output, the answer, are known. Gen AI evolution stems from significant technological advancements in GPU-enhanced computational power, new algorithms, and the quality of foundation neural network models, housing billions of weights that are trained on datasets of tremendous size. These foundational models can then be used or fine-tuned for a plethora of general or more specific tasks. Two specialist neural network technologies have transformed Gen AI as well: Generative Adversarial Networks, that is GANs, and Transformer-based networks, like ChatGPT. GANs employ two neural networks, a generator and a discriminator, engaged in a conflicting game. The generator creates new content, while the discriminator evaluates its authenticity against real content. Taking animals as an example, the generator will keep getting trained until it becomes so good that it creates content that is indistinguishable from the originals, like this giraffe, for instance. Then we can use the generator network to generate entirely unique and novel content. The transformer networks are cut out for analysing inputs that are sequences. Let's use a word sequence like a sentence as an example. The network positionally encodes each word into a vector of numbers, indicating what the word is, what it means, and where it sits in the sequence. These vectors then pass into an encoder, where repeated layers of specialized operations and neural networks extract the key features from the sentence. These details, packaged up as an abstract set of numbers, get passed to a decoder. The decoder likewise uses specialized operations and neural networks, along with the encoder output to generate the output term by term. A key theme of these specialized operations in the encoder and decoder is self-attention and cross-attention. When you read something quickly, you will naturally hone in on certain words more than others to help you understand the passage. Self-attention in the encoder and decoder works exactly like this. Based on the words and connections, a number or weight is assigned to each word of your input to isolate the most important parts. In other words, self-attention allows a network to understand relationships between different elements in an individual sequence. The decoder also uses cross-attention. Cross-attention also allows a network to understand relationships between parts of a sequence, but it does this while attending to another sequence, in this case the output that we see. The inputs don't necessarily need to be letters either. They could be musical notes, numbers, images, and much more, so you can create things like musical compositions for outputs. The ability of generative AI to operate across distinct modes makes for an incredibly potent and versatile content generation tool. On that note, let's have a look at some conventional and also less conventional uses. Just remember though, all of this runs on huge matrices of weights and clever layering of neural networks. Banking and finance is well poised for Gen AI. AI-driven automated chatbots empowered by Gen AI can process natural language inputs and provide personalized round-the-clock assistance, augmenting customer satisfaction and retention. Alternatively, Gen AI can be used for fraud detection and prevention via analyzing large datasets in real time, enabling identification of anomalous transactions or patterns of fraudulent activities. Advanced predictive models developed through Gen AI can analyze complex market trends, enabling financial institutions to make informed investments and trading decisions. Gen AI plays a pivotal role in generating financial reports and forecasts. It aids in automating data analysis, facilitating the creation of accurate financial models. This also assists in devising future strategies and business plans. Speaking of AI and finance, this is an excellent time to introduce today's sponsor, Brilliant.org. Cut out for fellow lifelong learners, Brilliant is the best way to learn math, data science, and computer science in a hands-on, low-pressure digital environment, no matter what your skill level is. In fact, if you want to interactively learn more about the neural networks that we've already discussed, their inner workings, and how they can be used in computer vision, there's even a course on this. To complement this, supporting mathematics courses ranging from fundamentals to advanced calculus are there, challenging but vital new skills to add to your roster. If any of this sounds interesting, then you can follow the link brilliant.org/Chemify to get your free 30-day trial, and the first 200 of you will get 20% off on the annual plan too. Moving to scientific and technological R&D. In medicine, drug discovery is already being enhanced. Gen AI models can predict and generate novel molecular structures that have high activity with a particular protein, like a disease spike protein. These approaches have already reported high success rates in clinical trials, significantly expediting the drug development process. In genomics, Gen AI analyzes genetic sequences, predicting protein structures and models protein folding, shedding light on protein functionalities and their links to diseases. More broadly, one can generate and predict structures and properties of novel materials tailored for any application, not just medicine. Gen AI-powered telemedicine platforms may be able to aid in providing medical support to underprivileged areas. Gen AI's immense computational power can be leveraged for predictive modeling, combined with physics-informed equations in areas like weather forecasting, climate change predictions, and more. Using Gen AI to generate code for such models dramatically enhances software development by up to 56% in some reports. The slightly more daunting realm lies in robotics, where Gen AI algorithms facilitating motion trajectories, robotic control, and environmental training simulations combined with augmented reality paints a powerful toolkit for making intelligent systems capable of autonomous decision-making. Gen AI's versatility extends into marketing, sales, and media as well. In marketing, Gen AI's ability to create personalized content, be it advertisements, product descriptions, or campaigns, can cater to specific audience preferences. Sales strategies witness a transformative shift with Gen AI's predictive analytics and sales forecasting. Media industries further benefit from Gen AI's capabilities in content creation and recommendation systems. Gen AI doesn't come without its ethical and practical challenges though. The raw amount of computational power to train one transformer network contributes around 315 tons of CO2 emissions. If datasets used to train neural networks are imbalanced, this can cause biases in the output, perpetuating societal inequality. Privacy concerns emerge, as identifiable information may be used in outputs, threatening user privacy and enabling malicious content creation like deep fakes. Explainability suffers due to the inherent black box nature of Gen AI interfaces, hindering understanding of output generation. Nevertheless, Gen AI, an immensely exciting area, something that is already making its mark on our present-day lives. And as usual, please do consider subscribing, sharing, and signing up to Chemify's mailing list at chemify.com.